Okay, here's an example of a parametric function. Sometimes this is a single parametric function. You may reflect upon what the definition of function is and whether this satisfies that definition. You might suspect it does, since I've called it a function. They're sometimes also referred to as a set of parametric equations. So pay attention, not going to happen here. As in the last video, what we can do is we can pick some random and convenient values for t and then generate values for x and y. Now, since I've chosen a trigonometric function instead of picking -1, 0, 1, 2, I'm going to make my life a little easier, and I'm going to pick, say, 0, pi fourths, pi halves, pi, and maybe 5 pi fourths, 3 pi halves. See where that takes me. See if that's enough points. Okay, so x. Now we're going to our unit circle. Cosine of 0 is 1. Radical 2 over 2, which is 0.71. Cosine of 0. Pi is -1. Negative 0.71. And 0. Check your unit circle if you don't see where I'm getting these from. You should. Then we're going to be at 0.71, 0, and 3 pi halves, which is 0, -1. Okay, this is basic function land. We've got our equation, turned it into a chart. Now, we make graph. Bloop, bloop, bloop. Biggest x value is 1. Biggest y value is 1. See if I can fit that all on the screen there. So we've got our first point is that x is 1, y is 0. x1, y is 0. And that is, we label each of these with their t value here. Even this is the x-axis. This is the y-axis. We're graphing that point, but that point has associated with it t equals 0. T, as you may guess, might represent time. 0.71, 0.71, I'm going to estimate that. This is 1, so 0.71, 0.71. Maybe 0.71 right there. That's at t equals pi fourths. 0, 1. T equals pi halves. Maybe this is starting to look familiar. Let's see. -1, next point is -1, 0. Over here, t equals pi. Hey, wait a second. What's going on here? -0.71, -0.71. We're over here now. Chugging along over here into the third quadrant. And then around here. Take a second and see if you what do you think this is? What shape do you think this is? Pause the video, take a guess. What do you think would happen if we kept going? Pause the video, take a guess. Yeah, you didn't pause the video, did you? Anyway, what you might have guessed is that if we plotted some more points, it seems to be going along like this. Tra-la-la-la-la-la-la-la-la, all the way around here. And what this might look like is circular motion. Except you're not too sure if it's circular or not. Seems to look like a circle. So what we're going to do real quick is try to verify that it is indeed a circle. Well, how would we verify that it's a circle? We're going to do that algebraically. Up here, I'm going to have to kind of skip down. Maybe I'll rewrite the equations. Our equations are, right now, this is not necessary to do with all parametric functions. I'll have you practice this in the homework. But we're now looking at the graph and we have a suspicion. We think this might be a circle. I think it's a circle. I don't think it's a circle. I think it's a circle. I don't think it's a circle. Let's check it out and see if we can find out. We're going to slap some algebra on there. So we're going to take x, maybe you already see where this is heading. Cosine of t, y is equal to the sine of t. And we're going to do a little, what? Sorry, I'm writing and it's not on the screen. I rewrote the equations here. X is cosine of t, y is sine of t. I'm going to use just elimination, basic elimination. I'm going to solve this for t. Take a second, do that in your head. Very good. Inverse cosine of x, and then substitute it in here. Y is equal to the sine of the inverse cosine of x. Ooh, uh-oh. I sense a triangle trick. Okay, let's see if we can resolve that triangle trick. I'm going to do it quickly. Again, pause the video if you don't like it. Inverse cosine of some angle theta. Cosine is adjacent over hypotenuse. This has got to be x. This has got to be 1. By the Pythagorean theorem, this is square root of 1 minus x squared. So the sine of that is this over that. So this whole thing becomes square root of 1 minus x squared. Square both sides. And lo and behold, x squared plus y squared equals 1. Our suspicions have been proven algebraically. Okay? Just go back up and summarize that. Again, you might plot a parametric function. It might look like some crazy mess that you've never seen before. Or you might plot a parametric function and say, hey, I think it's a circle. And then, if you wish, you can use substitution to verify that it is indeed a circle. Almost done. I want to give you 2 quick problems to try on your own. I really do. I just have to find them. Actually, what I need to find is a piece of paper to write them. Here are the 2 problems. And I want you to go through the same process. I want you to plot. Plot the points. Take a guess at what you think it might be. And verify algebraically. That's what we just did. First problem. X equals, it's going to be a slight variation here. What if we're going to make x3 times the cosine of theta? We're going to make y2 times the sine of theta. Maybe you already have a guess. Plot the points. See what happens. Second one. We're going to go back to we'll get rid of the 3 and the 2 and we'll just make it cosine of theta. Wow, I meant t up there. You can use theta if you want. X is cosine of pi t, and y is sine of pi t. And if that all goes well and you really want to have some fun, I know that probably was fun, but this one's optional. Try making this one cosine of 3t. And this one the sine of 5t. See what happens there. Whoa.